Hi, everybody. Sean McElroy here with our Autoline exclusives. Joining me today is Fabian Alefeld from EOS. He's the manager of consulting for the company. And we recently just learned that you guys are all about 3D printing. But Fabian, can you give me a better idea of what you and your team do at EOS?
Sure. So I am part of a team that we call Additive Minds, which once I go through the explanation makes actually a lot of sense why we called it that way. As you heard in the previous interview, EOS has been around for 30 years or more than 30 years now. We've been in the industrial 3D printing space for a long time, but over the past 7 years or so, 3D printing as it is known now moved from what it was called rapid prototyping into the actual industrial use and into the industrial application for zero parts with in production environments. And with that shift, we realized, and the whole industry realized, that you need a completely new and different way of thinking when you develop applications for industrial production when it comes to 3D printing. And around those challenges, we started a team that we called Additive Minds, so adding value and adding a new mindset to engineers that transfers the knowledge that we have within our company to those users to really help the industry grow and to help the industry to utilize additive manufacturing to its fullest extent.
So you guys are the ones coming in, telling an automaker, supplier, somebody like that, at least in the automotive industry, what are the benefits of 3D printing? Is that right then? You're coming in, let them know what you guys are able to do?
Correct. So the interesting thing is that nowadays the question is not anymore, is additive manufacturing ready? The question that many organizations and managers and engineers have is, how do we get started? How do we get into additive manufacturing? And the biggest risk of companies just entering a new technology such as 3D printing, but also accounts for others such as augmented reality, such as artificial intelligence, is, how do we not get stuck in pilot purgatory? Because that's a very dangerous field to be in, where companies just can't get out of that trying phase and actually push the technology one step further into production. So that's when we step in. That's when we help companies to get themselves ready for additive manufacturing. There is, from our experience, a three-step approach of becoming a organization that uses a technology such as additive manufacturing beneficially. And that first step starts with being ready as an organization, so organizational readiness. The second step is to find a challenge within your organization where additive manufacturing actually adds value. And that's especially important to not get stuck in pilot purgatory, because you put yourself into a position where additive manufacturing gets you out of a challenge. And then third, and probably most importantly, is to also set yourself up for scalability. It is always good to have a small team within a company who understands the technology in depth, but the challenge then is, how do we scale that throughout the whole organization to really have a bigger impact and to utilize additive manufacturing not only as an R&D capability, but actually as a production capability.
Now, are you finding that companies are coming to you, or are you going to have to go to them to kind of give them the benefits of these of 3D printing?
I would say both cases are very much the standards. The question is oftentimes if companies do have some internal knowledge, sometimes people don't know what they don't know. And that makes it really difficult for some organizations to really understand, why are they not able to really go that one step further? Why are they still in a position where they just can't find that one use case, where they just can't seem to push into that next stage of development? So that's where we also proactively approach organizations where we feel like they might be a little bit stuck. How can we unlock those use cases within a company where additive manufacturing really has a bigger impact versus just in the prototyping department?
Is there an example that you can kind of talk about where an automaker either came to you or you went to them, and like a specific case of where they determined that additive manufacturing was the route that they wanted to go?
Sure. So one very interesting example is the company now known as Daimler Buses, back then known as EvoBus. Daimler Buses approached us with a challenge roughly, I would say 4 years ago, where they had the challenge of being in a position where they had a lot of working capital stuck in their warehouses. And as they are a bus company, there's of course certain regulations that push them into a position where they need to have a lot of parts on stock, or at least where they have to provide a lot of stock parts for a very long-term period of their vehicles. So over the course of the past 10 years or so, also the bus industry changed, where organizations that buy buses don't only look at buses from a capital investment, but from a total cost of ownership. Whereas supplying spare parts on demand became more and more important. And the only way around that without additive manufacturing is to even increase your stock level even more. So that's where Daimler Buses identified an opportunity for additive manufacturing to get rid of a large amount of warehousing cost by not having parts on stock, but by utilizing 3D printing for on-demand production. Since then, they've come a long way. They worked with us in various fields, and to give you an idea on how we work is that we always like to really focus on the education of those individuals within a company. So we educated a cross-functional team within Daimler on what are the benefits of additive manufacturing, what are also the limitations. You know, we need to have certain expectations that are feasible within an organization, to not go through a huge enthusiastic phase, but then we drop because we realize it's not possible. So we need to also have that discussion. But we then very quickly went through what we call part screening and selection, where we go through a portfolio identification phase. Which parts within your part portfolio can leverage additive manufacturing from a technological point of view? So where can the technology actually add value versus just substituting the manufacturing process? But also, of course, in that case, in the supply chain vertical, more importantly, where can we actually have an economic impact? And that means, how can we get rid of minimum order quantities? How can we get rid of last time buys and flip the switch into additive manufacturing? And Daimler now went through a whole process of that early stage identification, where we then put our engineers together with their engineers to develop those applications for the manufacturing process of additive manufacturing. And they're now in a position where Daimler already today produces more than 200 spare parts on demand just by using additive manufacturing. And that number is now significantly growing month over month, because they now have that internal knowledge and understanding and capabilities to not only print parts, but also to understand the value and the impact of additive manufacturing on their supply chain.
And that's a great point. You know, spare parts is got to be a perfect application. And I know even in our Autoline daily news program that we do, we did cover at least one of those stories where Daimler was talking about the spare parts that they're doing for their buses. Mm-hmm. And, you know, I think if I'm not mistaken, automakers have to keep around dies and stuff like that for stamping out spare parts for something like 20 years, if I'm not mistaken on that. And if you don't have to keep those dies around, which can be very expensive to make, and you can just print a part up when you need it, or print it in batches, is got to be fantastic.
That's correct. And the question is not only, of course, warehousing costs are significant when you keep those huge dies around. The question also is, in which condition are those dies? Which warehouse are they? What are they? What I said before, the quantities that I need, is it actually worth the investment to restart the production process with those old dies for, let's say, a quantity of 10 parts, or let's say 100?
Now, like with a company like Daimler, let's say, where they're already using 3D printing in one area, like let's say a company starts out printing with plastics, do you have to go back into that company and kind of resell yourselves again if they're considering metal, 3D printing metal pieces as well?
So The process of metal 3D printing and polymer 3D printing has similarities and also very is the same and different at the same time. So when we look at additive manufacturing on a metal side, it is what we call a cold process. The metal powder is usually at room temperature, and the laser that melts the powder at the parts of an application where we want a solid part melts that powder all the way from room temperature into a solidified or liquid and then solidified field. Whereas in the polymer side, we have a so-called hot process where the whole build envelope is already very close to melting temperature, and the laser only adds the final impulse to melting that powder. That leads to different implications for the design process. On the metal side, we do need support structures because we have a very big heat differentiation in between different layers and in between parts. So we need to take that heat out of the part into the build platform, whereas in the polymer process, the heat differentiation is not that big, and therefore we do not need support structures. That allows for completely different designs. On the polymer side, you actually have a little bit of a bigger design freedom in polymers than in metals. Nevertheless, the thought process of approaching an application from a completely different angle, of rethinking the problem space of an application and engineering this part for the actual solution and not for the manufacturing technology limitations, that thought process is very similar. So therefore, organizations can utilize that knowledge that they gain from a first project, whether it's metal or polymer, and apply it to the other technology. There is some additional knowledge transfer necessary, but they're already way further ahead than companies who would just start from zero.
Okay, so and then you were talking about in some cases you might need to have somebody that's maybe already on the inside that knows a little bit about additive manufacturing. Do you guys offer training and stuff like that and services beyond once they finally do sign on?
Correct. So the whole idea of Additive Minds is built around knowledge transfer. So we even started out not with consulting, but with trainings around how to design for additive manufacturing, how to develop new materials for the technology, but also, as I mentioned earlier, how to identify parts that's actually where additive manufacturing actually adds value to your part portfolio. So we have various different trainings. We just launched our what we call Additive Minds Academy, which is also e-learnings, where individuals can sign themselves up, where they get taken through e-learnings and live coaching sessions with our engineers in order to really develop themselves to become additive manufacturing experts.
I'm just curious, have you ever had anyone go, nah, we don't need your training, we'll figure this out ourselves, and then come crawling back to you, Fabian, we need your help? You ever had anybody like that before?
No begging, but of course, and I think it's natural, right? We all don't know what we don't know, and when you start out with additive manufacturing, maybe you take your first training, you develop your first, or you print your first parts. You do feel like you've learned a lot, but you know, at some point everybody hits a wall, and we've realized that internally with new engineers that we onboard that are straight out of college or transition from a different technology. You know, it's the natural progression where you hit a high and all of a sudden you hit a low, and it always is nice to have somebody that kind of guides you through that hole, that may even teach you some of the mistakes that you will be making up front and teaches you how to mitigate those and how to really get a better understanding on why certain things fail. If you look at additive manufacturing, it is a micro welding process on a micron level. There's a lot of things that can go wrong, and you really need to understand the process in depth to predict those challenges upfront within your product development cycle. And if we look at the industry today, I would say, which I think is actually good news for engineers, is that there's a lot of software out there that can aid the engineer in their development processes. Nevertheless, the capabilities of the technology are higher than the capabilities of software. And that gap can only be filled by an actual engineer who understands the use case and the application in depth, who understands the technology of 3D printing in depth, and then fills that gap that actually then makes the big difference in pushing that technology into an actual viable production part.
Yeah, I mean, I believe that it's got to be quite difficult. In automotive, any system can be amazingly complicated. We just did one of these interviews with someone that showed us a 1,000-page book that he had written solely on automotive Ethernet. So yeah, I can understand how 3D printing could be quite complicated. And
yeah, yeah,
so,
and
go ahead.
Yeah, and I think we're now in a time where new technologies get introduced on a yearly basis, and especially engineers, I think, struggle with the fact of information overflow, struggle with the fact of which information actually applies to my field. So yeah, we really try to guide that decision process, to guide that process of where do you apply additive manufacturing first? Where does it have the biggest impact? Is it because you can actually gain a competitive advantage over your competitors? Is it because you have certain bottlenecks within your production, and we can fill those bottlenecks by implementing new solutions, by printing parts? Or is it because, as I mentioned before, your spare part business is quite critical, but it gets hard to manage with the increased amount of customer demand?
Well, that's a great point and kind of leads into my next question here. I mean, I got to imagine with all these new technologies coming out and people are just rushing to get, whether it be electric or autonomous out, ADAS technology, I got to imagine that people are trying to think of new ways to find solutions to problems that they have. And are those the areas where you're seeing a lot of growth?
Yeah, and that's the perfect application for additive manufacturing, right? We have a lot of legacy in industries such as automotive, where we just gradually redevelop ourselves and gradually get better from one program to the other. Whereas now we're in a position where the automotive industry, but also other industries, are being challenged by new entries into the market that weren't there 10 years ago. And having that open mindset that you just mentioned in, reassessing what we've been doing for the past 100 years, thinking if we can do something differently, and then using those new technologies such as additive manufacturing to really unlock those new potentials and pushing into new business models, pushing into what BMW is doing with their customized mini parts. Now all of a sudden users can customize their vehicles online and get a 3D printed part, such as this one, a side signal that is 3D printed, or all of a sudden I can produce vehicles that are higher performing because I can reduce the weight by utilizing additive manufacturing, and so on and so forth. So really thinking of additive manufacturing as a technology that unlocks new potentials in the future, but also can mitigate certain challenges in the present.
Yeah, no, it's just very exciting to think about and see the new applications that are going to end up coming about with everything that's going on. I just find it very cool. It is,
and it's just the beginning, right? We're currently working on a project with Daimler and Premium Aerotech, which is called Next Gen AM, so next generation additive manufacturing, where we're talking about a fully automated and digitized manufacturing facility where actually the aerospace industry and the automotive industry come together to utilize systems and to utilize manufacturing floors to the fullest extent. So now we're becoming more sustainable. Now we are becoming more flexible, more agile. We're building up local manufacturing hubs versus having one large factory in one location and shipping parts all over the world. So it will have an impact not only on auto manufacturers, but also on the way that we build up sustainable supply and manufacturing chains in the future.
Well, it sounds like there's a lot coming, and it sounds like we're going to have you guys back at some point because there's more news coming. So
yeah, always love to share the news.
Yeah, Fabian, I want to thank you for your time today. Really appreciate it. It's really cool to see, kind of the process that an automaker might have to go through to make that decision to switch from, a process that they may have been doing for 50 years or more and, switch to something completely new. So I find that very interesting.
That's correct. And yeah, thanks for having me. I had a lot of fun. And if anyone has any questions, please feel free to reach out. We're always there to help you out and talk about some challenges that your listeners might have.
Fantastic. Thank you very much.
Thank you.